welcome to my channel. This is Parvati Arnayar and today we are going to start the topic of vertical circular motion. So when a body is exhibiting vertical circular motion, it is having an acceleration. So let us consider a body moving in a vertical circular path. So you can imagine the vertical circle as in the case of a Ferris wheel. In a Ferris wheel, when the people are sitting on the benches and they are rotating, it is an example of a vertical circular motion. Let's consider a bob of mass m that is tied to a string, and the string has a tension T and the string has a radius r. Let's take the radius r and the bob has a mass m. Now this is the lowest point, this is the highest point of the vertical circle. Now let us take an arbitrary point P. At any point, let's say that the mass is at any point P. At the point P, the mass is connected with the string. It is having a tension T and it is at an angle theta with the vertical. It is at an angle theta with the vertical. So this is a vertical and this is a horizontal. So we can mark the horizontal. This is the vertical direction and now this angle theta is with the vertical. So this theta is varying as the particle moves, as in the circular motion. This theta is varying from 0 degrees to 360 degree in a circle. So the particle is moving in a circle. So it is varying from 0 to 360 degree. At the highest point H, this theta will have 180 degree. Theta here is called 180 degree. Then we will take this as the middle point M, and the middle point theta has the value 90 degree. See here in the middle point theta has the value 90 degree. Okay. So now let's put all our focus on point P. So at the point P, now we have to consider laws of motion, the properties of laws of motion. So here the mass is acting downwards, the weight of the body is acting vertically downwards. The tension is acting up here. Now we have to split the components, and that is we have to split components. Otherwise, only then we can solve. So here we are marking the vertical and the horizontal. This is the horizontal, this is the vertical. This angle is theta. That means by alternate angle property, this angle is also theta. Got it? So since this angle is theta, we can mark this angle is theta. So since this angle is theta, we can mark this angle as theta too. See, this angle is theta, so by alternative angle property, this angle is also theta. So here we are drawing another axis to this. ഇവിടെ നമ്മളൊരു ആക്സിസ് വെച്ചാൽ നമുക്ക് ഈ ആംഗിളും തീറ്റ ആയിട്ട് കിട്ടാം. ഈ ആംഗിൾ തീറ്റ ആയിട്ട് നമുക്ക് മനസ്സിലായി കഴിഞ്ഞാൽ then we can make this component as mg cos theta and this component as mg sin theta. Here we are splitting mg, the weight, into two components, mg cos theta and mg sin theta. Now this is point P. Body's weight is acting vertically downwards. This is mg cos theta. This is theta. And this is mg sin theta. When a body is moving in a circular motion, it is always having a centripetal force. And the centripetal force has the magnitude mv square by r. And the centripetal force is acting towards the center of the circle. So here also in the vertical circular motion there is a centripetal force, and the centripetal force is acting towards the center of the circle. So we take the point P. At the point P also there is a centripetal force acting, and this centripetal force acting is towards the center. സെൻറ്ററിലേക്ക് ആക്ട് ചെയ്യാണ്. അപ്പോൾ ഇത് സെൻറ്ററിലേക്ക് ആക്ട് ചെയ്യുമ്പോൾ നമുക്ക് a centripetal force, we can write the centripetal force as ഈ centripetal force കൊടുക്കുന്ന tension ആണ്. The tension is providing the centripetal force for the motion of the ball. So tension, now this tension is providing, but this mg cos theta is minimizing the centripetal force. This tension is providing, but this mg cos theta is reducing the centripetal force. So now we have to reduce mg cos theta from this. Okay. So now we can write the tension of the string T as mv square by r plus mg cos theta. This is an important relation in the vertical circular motion. The tension of the string in a vertical circular motion is mv square by r plus mg sin theta. So, mv square by r is the centripetal force that is acting towards the center of the circle, and this centripetal force is provided by tension of the string. Tension of the string is providing the centripetal force. You can see here the centripetal force is provided by tension, but it is it is reduced. The centripetal force is reduced by mg cos theta. Mg cos theta is reducing the centripetal force. This mg cos theta is pulling the bob towards the downwards area, but the bob needs to continue its path, circular path. So for that only the tension is helping it. So tension is helping, mg cos theta is not helping, so we are minusing it from tension. And this square by s, rearranging, we will get the tension's equation as this. See here, we have a term cos theta. This cos theta is the only one varying from the lowest point to the highest point. Theta varies, so cos theta varies. So this tension will have maximum value when cos theta is 1, and it will have minimum value when cos theta is minus 1. So we know that cos theta will become 1 when theta is equal to 0, and that is the lowest point. The lowest point that it has maximum tension, and when cos theta is minus 1, that is theta is equal to 180 degree, that is the highest point this tension has lowest value. So here we can take that tension at the highest point approximately equal to 0. Let me just write there. Now we have to change this equation into a more suitable equation. So before that, we will consider the mechanical energy conversion. At the lowest point, the body has a velocity u. At this point P, let's say the body has a velocity v. Looking closely, we can see that this point, at the point P, the bob is a little bit higher. That is, it has traveled a distance h from the horizontal. It has traveled a distance h from the horizontal. Therefore, we can say this as r minus h. This was the radius, that is the length of the string, radius. Now this point P has reached a height h from the initial point, so we can mark this as r minus h. We take cos theta. Cos theta is equal to, so this is the radius, okay, this from this point O to this point P, that is the radius. Now cos theta is equal to adjacent side by hypotenuse, that is r minus h by r. So we are taking this triangle, okay, we are taking this triangle into consideration, OP sum S. Okay. So this cos theta, we get the value of cos theta. We can substitute in here, but before that we have to also substitute v square. So we know this initial velocity is u, this final velocity is v. Now applying the mechanical conversion, total mechanical energy remains constant, we can say that half mv square minus u square is equal to mgh. Change in potential energy is equal to change in kinetic energy. Loss in potential energy is equal to gain in kinetic energy. As simple as that. Now cancel the m's and we get v square is equal to u square minus 2gh. U square plus 2gh. Actually it's minus 2gh. Okay, so I have drawn it aside. See, now we are applying mechanical energy conversion. According to mechanical energy conversion, kinetic energy at the lowest point plus potential energy at the lowest point is equal to kinetic energy at point P plus potential energy at point P. Kinetic energy at the lowest point is half m u square, since the initial velocity is u, plus potential energy at the lowest point. Here the lowest point, it has no height, therefore potential energy is 0 at the lowest point. At the highest, at the point P, the kinetic energy is half mv square and the potential energy is mgh, since it has no the height h. Now we cancel the m's. We get u square is equal to v square plus 2gh. Shifting v square is equal to u square minus 2gh. V is equal to root of u square minus 2gh. This is an important relation in vertical circular motion. Now in the equation of tension, we substitute the values of V and cos theta. We will get T is equal to m. We substitute V square. V square is u square minus 2gh divided by r plus mg cos theta is r minus h divided by r. So we can take this as capital R, because that's the radius, right? Now we take m and r outside, then we will put a plain bracket u square minus 2gh plus r plus, so this g is there, gr minus gh is equal to m by r into u square minus 3gh plus gr. Ta-da! We got the tension, and this is the tension of the string. That is m by r into u square plus 3gh plus gr. So this is the tension of the wire. Now we got the tension at the point, at any point, which will vary according to height. So here height is the one varying. Here we are considering height. Earlier we considered theta as a varying thing, varying quantity, but that was not very good. So now we are considering height, h as a varying point. So if you look at it, നമുക്ക് മനസ്സിലാവും ഈ ബോഡി ഇവിടെ നിന്ന് എമ്മിലേക്ക് ട്രാവൽ ചെയ്യുമ്പോഴത്തേക്കും അതിൻ്റെ ഹൈറ്റ് will become what? It will become equal to the radius, because now when the body is traveling from the lowest point to the point M, the height is the radius. So we can substitute this h by r, and we will get that tension at the point M is equal to m by r into u square minus 3gr plus gr m by r into u square minus 2gr. So we will get this equation. This is the tension at the point M. Okay. So likewise, we can find the tension at other points. So when theta in the question, it all depends on the question. In the question, if theta is given, we use this equation mv square by r plus mg cos theta. Now, if the height is given, we can write t as m by r into u square minus 3gh plus gr. This is the also equation for tension. These three equations are definitely important in vertical circular motion. Now, let's see when this blob of mass m is undergoing the circular motion, we assume that at the highest point, the tension is approximately equal to 0. Tension is approximately equal to, so that is tension is minimum at the highest point and it is approximately equal to 0. So when tension at highest point is approximately equal to 0, in this equation we can substitute T as 0 and H as what? 2R. Because at the highest point, then the particle has undergone a dist height of 2R. Substituting all this in there, so here tension is approximately equal to 0, m by r into u square minus 2g into 3g into 2r plus gr, m by r into u square minus 5gr equals 0. So here from here we get u square is equal to 5gr and u is equal to root 5gr. Now this is an important relation. U is equal to root 5gr means if the particle has to undergo this vertical circular motion completely, then it should have at least a maximum initial velocity of root 5gr. Only then it can complete the whole vertical circular motion. So the minimum required velocity is root 5gr. If any value of initial velocity less than root 5gr is there, then the particle cannot undergo the whole circular motion. It will either stop at this point at somewhere between L and H, or it may undergo a projectile motion, or it may oscillate like a pendulum, and but it will never complete the whole circle. If the body wants to complete the whole circle, then it should be projected with a velocity. It should be given an initial velocity that is greater than or equal to this root 5gr. So this is the velocity at the initial velocity at the lowest point, root 5gr. So thus the vertical circular motion part 1 has come to an end. Hope you like my video.